Let's start with few problems. See the first one. If a line has direction ratios of 2, -1, -2, determine the direction cosines. Direct application of formula. Okay, so the first one. The formula is what? L is equal to plus or minus a by root of a square plus b square plus c square. Correct? Same thing goes with m, same thing goes with n. So here, what we'll do, L is equal to plus or minus a value is 2, 2 divided by root of 2 square minus 1 square, or 1 square is the same, right? 1 plus 4. 2 divided by 4 plus 4 is 8, 8 plus 1 is 9. Root of 9 is 3. Plus or minus 2 by 3. Correct? Next, m value plus or minus minus 1 divided by again 3. So here we can write this as minus or plus 1 by 3. Okay? Then n value again plus or minus minus 2 by 3 or minus or plus 2 by 3. So what are the answers now? We can write plus or minus 2 by 3, minus or plus, sorry, this is minus or plus 1 by 3, minus or plus 2 by 3. These are the answers for the first one. Very simple. Clear? This is the answer for the first one. Let's do the next one now. See the second one. Find the direction cosines of a line which makes equal angles with coordinate axis. Correct? Equal angles with coordinate axis. In other words, we can say that, see, it has to be an equal angle, right? With alpha is equal to beta is equal to gamma. This is what it is. That means for the second one, since alpha is equal to beta is equal to gamma, we can say that L is equal to M is equal to N. Correct? So what do we have? L square plus M square plus N square is equal to 1. Since all the three are the same, we can say 3L square is equal to 1, or L is equal to plus or minus 1 by root 3. But since it's the same, L, M, N are the same, we are going to get the direction cosines, DCs. DCs are plus or minus 1 by root 3, 1 by root 3, 1 by root 3. This becomes the answer for the second question. Very, very simple. Let's do the third one. See the third one? If a line has a direction ratios of such things, what are its direction cosines? Again, it's very similar to what we did in the first question, isn't it? First, what we'll do, we'll calculate root of a square plus b square plus c square. So we'll have root of a square plus b square plus c square. Root of, guys, 18 square or minus 18 square is the same. 324 plus 144 plus 16, which gives us root of 484. Root of 484 is what? 22. Correct? Now comes the value of L, M and N. L value becomes plus or minus 18 by 22, which is nothing but, see, 18 by 22, which is 9 by 11, minus or plus 9 by 11. Next, M value plus or minus 12 by 22, plus or minus 6 by 11. Next, N value plus or minus 4 by 22, which becomes minus or plus 2 by 11. So final answer, minus or plus 9 by 11, plus or minus 6 by 11, again minus or plus 2 by 11. This is the answer for the third one. Clear? Let's do the last question now. See the fourth one. Show that the points this are collinear. Here we'll use the direction ratio. Okay, now direction ratio is nothing but x2 minus x1, y2 minus y1 and z2 minus z1. This is the direction ratio. If the direction ratios are the same, then we can say that they are collinear. Okay, so for the first thing, what we'll do, we'll take 2, 3, 4, minus 1, minus 2, and 1. Let's calculate the direction ratios now. Minus 1, minus 2, minus 2, minus 3, 1, minus 4. Okay, first case. Second, what we'll do, we'll take the next point, minus 2, minus 1, minus 2, 1, and 5, 8, 7. Here also calculate. 5 minus of minus 1, 5 plus 1, then 8 plus 2, then 7 minus 1. We'll calculate this one. See, minus 3, minus 5, minus 3. Correct? This is going to become 6, 10, 6. Correct? 6, 10, and 6. Now, if you look at this, minus 3, minus 5, minus 3, 6, 10, and 6. What is the common term, common ratio here? Minus 2, correct? That means if you take the first one, multiply this by minus 2, what do you get? 6, 10, and 6, which is nothing but the direction ratio of the second one. So this proves that these 3 points are collinear. Clear? So these are 4 simple problems on the topics whatever we have discussed so far. Now in the next video onwards, we'll look into the next topic in 3D geometry.